Hello friends, we have this integration in our hands. Whenever you have to solve for an integration like this, you have to express the whole terms in a known form of integration that we have. First, I will demonstrate an idea, a way that is wrong. So whenever we see these x square terms, x to the power n, x to the power n or x to the power p terms basically, we tend to express this whole things in a way that denominator is single term. What I mean by that is, let us take for this instance x square plus 5 equals to t. Maybe this is the way to go here, because if we do this, the denominator itself will convert into a single term. So for here it will be t, and the rest of the term we have to express. So what are the rest of the terms? One is x square, another is dx. So in order to express in order to change the x square term, what we will have to do is, x square is straightforward, it is simply t minus 5. From here we can write that, so it will be t minus 5, but changing this dx term is tricky. So x square plus 5 equals to 2, this is known. So this is equal to t, this is known. And now then x square equals to x square plus 5. If you take the d both ways, d operator both ways, it will be dt. Now this is 2x dx, 2x dx equals to dt. Now once you know this, 2x, what is 2x? So from here we know that x equals to under root t minus 5. Hopefully you have no confusion in this one. And t minus 5, uh, 2 t minus 5 dx equals to dt. We can write it in this way. So finally what we have in our hands is dx equals to dt y 2 t minus 5. Now we have to substitute this term in this equation. So if we try to do that, what will come is dt by 2 t minus 5. So this whole term turned out to be, let me just change this. Yeah, this whole term turned out to be t minus 5 to t under root t minus 5 dt. Now we went out to make this problem simpler. We have made it more complicated. Dealing with this term is much complicated than dealing with this term. So we'll try a different method. We'll try to find out a different expression from which we can deal with this simply. So another integration is known, which is dx by x square plus a square. If you do this, it will be tan inverse x by a. Of course, there will be 1 by a term somewhere here, and we can't forget the constant c. So we will try to express this whole thing in this format. So in order to do that, what we'll have to do it, we have to, in the integration terms, first in the numerator, we have to express the same thing as in the denominator, and then we have to minus the extra terms 5. Why we are doing it will be explained shortly. So here we have a term like this, 1 dx minus, we take 5 outside, and it will be dx x square plus 5. Now this is very easy, very simple. We can simply write it as x. Of course, plus you won't write here. We'll consolidate all the pluses and we'll have a single constant term later on. And now this is 5. Now of course this plus 5, we can write this term, specifically this particular term, as root 5 square. Right, now taking root 5 as a in this term, we will write this as tan inverse x by root 5, and of course we can't forget the a term outside. Right, now this whole thing transforms to a final expression, which will be like this: x minus 1 by root 5 tan inverse x by root 5 plus c. This is the answer. Hopefully this particular problem is clear to you. We will come again with another problem in another concept in another video. See you then.